In this video, I'll be helping you with the ALEKS problem type called finding coordinates on the unit circle for special angles. In this example, we're asked to find the terminal point on the unit circle determined by 5 pi over 3 radians and to use exact values, not decimal approximations. And since we're looking for special angles, we'll start by looking at all of those special angles on the unit circle, and since we'll want to memorize all of these, or at least be able to create them, recognizing the pattern will help us do that. We'll start by looking at the multiples of pi fourths. On our diagram here, I've labeled all the multiples of pi fourths, starting with 0. That would be 0 times pi fourths. 1 times pi fourths is just pi fourths. 2 times pi fourths would be 2 pi fourths, but that simplifies to pi halves. Next, we would have 3 times pi fourths, or 3 pi fourths. And from here, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths, and one full circle would be 8 pi fourths, which is 2 pi. So the multiples of pi fourths give us many of the special angles, and we would also have the multiples of pi sixths. 0 times pi 6 is 0. 1 times pi 6 is pi sixths. 2 times pi 6 would reduce to pi thirds. Continuing, 3 times pi 6 simplifies to pi halves. And now that we see that pattern, we can tell continuing, we would have 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, 11 pi 6, and 12 pi 6, which is again one complete circle, 2 pi. And from here, once we've generated all of the special angles, and we know that this circle has a radius of 1. So on the coordinate plane, this first point here, the circle has a radius of 1. So the coordinates here would be 1, 0. Similarly, here at the top, the x-coordinate is now 0, and the y-coordinate is 1. And knowing the coordinates along those axes, we can now use another pattern to fill in any of the missing values. I'll start with the x values. In this first quadrant, I can think of 1 as the square root of 4 over 2, and then going down, I would have the square root of 3 over 2, the square root of 2 over 2, the square root of 1 over 2. The square root of 1 is just 1, so this would be 1/2. And then the square root of 0 over 2 is 0. And the y values follow that same pattern, just in the other direction. The square root of 0 over 2, then the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and then the 1 is the square root of 4 over 2. Once we have this first quadrant, we can use the symmetry for the unit circle to fill in all of the others. So for example, here at 2 pi thirds, this is the mirror image of this point. Instead of a positive 1/2, our x-coordinate would be negative 1/2, with the same y-coordinate, the square root of 3 over 2. The next one is the mirror image here, again with a negative x value. So negative square root of 2 over 2 and square root of 2 over 2. The same for 5 pi 6. It's the mirror of here. With a negative x value, we would have negative square root of 3 over 2 and 1/2. And from here, we could continue to use symmetry to fill in the rest of the values. However, the one that we were asked about is this one, 5 pi thirds. Since I know its mirror image here in the first quadrant, this would have the same x value, 1/2, but the y value would be negative. So negative square root of 3 over 2. So this would be the coordinates of the point on the unit circle at 5 pi thirds, and we can get there by recognizing the pattern for both the special angles and the pattern that the coordinates follow.